Remarkably, in history, we've seen the continents move apart and then come together and move apart and come together in different places around the world. And during the Cenozoic time period, when these large-scale crustal processes and mechanisms were in motion, they had a dramatic effect on what was going on in terms of global evolutionary biology. And so one of the mechanisms that was laid out by Darwin as a way to generate new types of species was something called allopatric speciation. And that is the idea that once you have some kind of a physical process, like a mountain built, a new glacier forming, volcanics that shut off land areas where you could have migration, you have flooding and suddenly have a new ocean pathway that was formed. Any kind of a physical barrier that could prevent the migration of organisms back and forth would be a good way to have the gene pools via sexual reproduction isolated from each other and then generate a new group of organisms. And so this idea of allopatric speciation, geographic separation, enhancing the ability to radiate new species has been a really important tenet in looking at the evolution of macro eukaryotic organisms. We've seen that played out extremely well in terms of North and South America as one example. So let me just go through the details of this North-South America's contextual stage, and then we'll see how the drama played out over the organisms between the two different continents. So with respect to South America, South America rifted from Africa in about the late Cretaceous. So again, this is a late Cretaceous going into Cenozoic ongoing process that took place. And once that we had the separation from Africa and South America physically, then we started seeing that marsupials and placental herbivores migrated to South America. And again, this all took place at the end of the Cretaceous. And once that isolation continued and the ocean became larger, the southern part of the Atlantic, then that isolation locked in and the allopatric speciation kicked in. And so we saw this remarkably play out for South America. So the mammals were dominant then and remained on Africa, and then the marsupials took over and capitalized on the South American continent. Remarkably, we saw all kinds of evolution of marsupials, which ended up looking a lot like the placental mammals that had remained back on Africa, but they filled the same kind of ecosystem space, but they were definitely not placental mammals, they were marsupials. And some of the largest carnivores that we've had on the planet in the Cenozoic time period were actually saber-toothed marsupials, and we'll see that in just one moment. So if we look at kind of an overlay of what some of these organisms look like, we'll see that we had a one-for-one counterpart between Africa and South America. And in terms of the wolf-like organisms, the placental wolf, there was a Tasmanian wolf. Again, it was a marsupial, not a placental mammal. A flying phalanger versus a flying squirrel. We had an anteater developed that were both marsupial and placental. And then we had, as an example, moles that were developed that evolved that were both either placental or marsupial. So we had this one-for-one exchange, and we've seen this before when the same kind of ecosystem allows the radiation and dominance of a different organism that looks somewhat similar to what was there before. We've also seen this play out on the stage of Australia, of course, and even until recently, Australia has been dominated by the marsupials, kangaroos, wallabies, wombats, phalangers, koala, all kinds of organisms. So, but what's happening in the modern day is that human beings introduce invasive species, and these species have outcompeted many of the marsupials. So it's causing some dramatic shifts in the ecosystems of Australia. So going back to North and South America, there was this great drama that was played out when we had the two continents go from being isolated. The placental mammals were dominating on the North American continent, similarly to what happened in Africa. And again, the South American continent, when it separated, the marsupials dominated there. And we call this the Great American Interchange of the mammals. So before the Isthmus of Panama in Central America rose up in the Cenozoic, those two continents were isolated. Once that rose, then it was a pathway for organisms to intersperse and come together. So that land bridge allowed the invasion of marsupials to the north and the placental mammals to the south. Now, unfortunately for the marsupials, whenever marsupials compete with placental mammals, we find that they don't do well, and they get outcompeted and are oftentimes driven to extinction. And we saw this played out very quickly in the Paleocene time period when the Central American landmass was brought up. Now, some of the things that migrated back and forth from North America to South America were the bears, the camels, the cats, the deer, the dogs, raccoons, skunks, tapirs, some of the organisms that we're familiar with still from the modern-day North American template of what lives here. The ones moving northward, anteaters, armadillos, opossums, porcupines, sloths. We had this great exchange that took place across this interface. Well, unfortunately, again, the marsupials consistently lost out in most of these areas where the exchange took place. But one of the ones that are most remarkable that I want to point out are the marsupial saber-toothed tigers. Now, when you say the word saber-toothed tiger, it brings up an immediate image, right? The large fangs and the incisors, as we see in this kind of this reconstructed diagram, and fearsome predators that are dominating the landscape. But even more fearsome than the North American placental saber-toothed cats were the South American marsupial saber-toothed cats, and more fearsome because they were even larger, but also they had even bigger fangs that came down. Their canines were even bigger, and they were so large that they evolved a sheath. So as we see in these fossils here, there was a bone sheath that developed down from the jaw. And so when the incisors were closed, when the mouth was closed, they were so long and strong and sharp that they developed these bone masses to keep themselves from stabbing themselves. So here's a reconstruction of one of these South American marsupial saber-toothed cats. And these were actually larger than the North American saber-toothed placental cats. But in the end, they lost out. They were unable to compete on a consistent basis. So again, the concept of geology, the moving of the continents, the development of ice sheets and volcanics and all kinds of physical impediments to having organisms move back and forth and be able to interbreed between themselves has been very important in geological time. But then equally important is having these physical barriers dropped. And in the case of North and South America, this landmass developing that allowed the exchange of the mammals and seeing the mammals from the placental lineages outcompeting the marsupials.